In section 3.4, we're going to be writing equations. As we read this first problem, we're going to highlight the things that are important in our problem. Write an equation of a line with slope of -3 and containing the point, so of the point 1, -5. Write an equation in slope-intercept form. So that's three important things that we need to know. And for slope-intercept form, we need a slope, we need an intercept, and then we need to plug it into our formula, slope-intercept formula. So I've set the table up already, and we're going to pull information as we go. The slope was given to us, and said slope is -3 in the original problem. So that part was very basic. Our y-intercept, which is our b, was not given to us, so I start with the formula, and I'm going to substitute these values. This is going to go in for my x. X is 1. This is going to go in for my y, -5. My m comes from the previous portion right here. And then plus b. I'm solving for b. So now I just solve this out. -3. Get b by itself, so add 3 to both sides. We're going to have -2 is equal to b. Once you have your m, once you have your b, the last step is to plug in the m and plug in the b. So y equals -3x, and then my b is -2. So this is the equation in slope-intercept of a line that has a slope of -3 and goes through the point 1, -5. Problem number 2 tells us that we're going to write an equation of a line through the point 4, 0 and -4, -5. Write the equation in standard form. So we have, when we highlight the important things in here, we have the point, we have 2 points this time, and we want the equation in standard form. Before we can go to standard form, we need to go to slope-intercept form, which is what we did in the previous problem right here. We're going to fill this table in, and then we're going to take the next step and put it in standard form, which is this in blue. And take a second and read this note about standard form as well. We're going to start with the point, finding the slope. That's going to be our formula, y2 minus y1 over x2 minus x1. They gave us 2 points. This is our x1, y1, our x2, y2. So when I plug that in, I get -5 minus 0 over -4 minus 4. When I simplify that, I'm going to have -5 over -h, which simplifies to 5/8. Okay, I come back up and I need the same process to find my b. I can choose either one of these points. I'm going to choose to use the point 4, 0. I can choose either one, but I'm going to use the point 4, 0 to substitute. So I substitute 4 in for my x and 0 in for my y. My m is 5/8 from the previous column, and I solve for b. So 0 is equal to, I'm going to simplify, I'm going to cross cancel, divide by 4, divide by 4, now multiply straight across, and I get 5 times 1 is 5, 2 times 1 is 2, so you get 5 halves. Subtract 5 halves from both sides, and that gives us -5 halves is equal to b. So my last step is to plug in m and plug in b from the previous two columns. So y equals 5/8 x minus 5 halves. Okay, once we have our formula in slope-intercept form, we now want to transfer it to standard form, which means x and y are both on the same side. So the first thing I want to do is I'm going to move x and y on the same sides. So I'm going to subtract. If I have y equals 5/8 x minus 5 halves, I'm going to move x over by subtracting 5/8 x and move it to this side. That now gives me -5/8 x plus y equals -5 halves. Now if we stop right there, we said the a value, which is the coefficient in front of the x, cannot be negative or a fraction. The first thing we want to do is take care of the fraction. If I get a common denominator between this and this, it's going to be 8. So if I multiply every term in the problem by 8 so I can get rid of the fraction, I'm going to now simplify. Divide by 8, divide by 8, so I get 1 times 5 times negative 5 is negative 5x, plus 8 times y is 8y. Divide by 2, divide by 2, and then you get 4 times 5, negative 5 is negative 20. Now it's not a fraction any longer, but I also don't want my coefficient in front of the x to be negative, so my next step is to change all the signs of each one of the terms in the problem. So I get 5x minus 8y equals 20, and this is standard form. So for standard form, first of all, we just go to slope-intercept, which is our previous method for solving. After we get there, then we're just going to move x and y on the same side, and if there's any fractions, we get rid of the fractions. If the coefficient in front of the x is negative, then we change all the signs. And we have ax plus by equals c. That's formulas for standard form. Okay, number 3, write an equation. Write an equation of a horizontal line containing the point. That's our information. First of all, horizontal line means that it looks like this. That's horizontal, and we also know a few things about that. We know the slope is 0, and we also know that all horizontal lines are y equals some number. The equation is y equals some number. The only thing we know about y is in this point the y value is 3. Therefore our equation is y equals 3. So that's very basic. And likewise, in problem number 4, it says write the equation of a vertical line, and it goes through the point 2, 3. Well, a vertical line looks like this, which has a slope of undefined, and that always has vertical lines have an x equals some number format. So we have x equals, and the only number we know that x equals is in our pointer, x equals 2. So this is going to be the equation of our line. And a quick graph of those, they didn't ask us to graph it, but I would go over 2 and then I would draw a vertical line. This would be x equals 2, and on this previous one up top, if y equals 3 would be a horizontal line right there. So that's a brief review of writing equations in section 3.4.